All right, probably going to break this up into two videos. One of them is going to be volume, one of them is going to be surface area. So starting with volume, it's going to start with a prism, then a cylinder, go to a pyramid, then a cone, and then go to sphere. I'll be using a calculator. I highly suggest that you use one too, because you can. So for prisms, prisms are anything that are connected by rectangles. So you could name any shape, a rhombus. If rhombus was connected by rectangles to another rhombus on the other side, the base would be a rhombus, and it would be a prism because it's connected by rectangles. So you can see on this rectangular prism, the reason it's a rectangular prism is because it's a rectangle connected by rectangles. You could have a square, pretend that's a square, connected by rectangles, and it's still a rectangular prism, not a square prism. I guess if you wanted to call it one, you could. I would know what you're talking about, but just to get the names out of the way. And you can see that the only two pair of parallel sides over here on figure number 2 is the triangles. So that would make it a triangular prism. The parallel sides are where you're going to define your base. And the reason it doesn't matter on a rectangular prism is because all the sides are parallel to each other. At least opposite sides are parallel. So let's take a look at the first one and just go through the formula. These are pretty basic. It's not really a big deal. Let's go with 2 by 4 and then the depth of this. And the only reason I know the depth is because I'm going from the front to the back, and its base to base is going to define your height of any prism, cylinder, anything. So let's say that's 5. So to find the area of the base, which we said was going to be that front rectangle that I highlighted in orange, the area of a rectangle is going to be length times width. The volume of a prism, a rectangular prism especially, or a cube, is very straightforward. It's going to end up being multiplied with 3 numbers, length times width times height. Even used to say that on the formula chart, but then they changed it to the area of the base because you should know how to find the area of a rectangle. So length times width, the length is 2, the width is 4, and the height, the distance between the front to the back, the distance between bases, is 5. 2 times 4 is 8, and 8 times 5 is 40. Since we're finding volume, it's going to be cubic units. We're talking about cubes fitting in there now. That's why it looks three-dimensional. That's why there's a little baby 3 right there. It stands for length, width, and height. Looking over at the triangular prism. Again, it's a triangular prism because the only two sides that are parallel are the triangles, and they are connected by rectangles. That's what makes it a triangular prism. The height of the triangle, let's say, is 10, and the base of the triangle is 5. So going back and thinking about two-dimensional figures, where the h, how tall the h is the height, and then whenever you do this, it turns into a b. That's where the base is at. So the area formula, so capital B, is base times height divided by 2. So if you wanted to substitute that in for the volume formula, it would look like this. V equals base times height divided by 2 times the height of the prism. The height of the prism is going to be the distance between the bases, which are triangles. So let's go with 6 there. So let's go ahead, find the area of the base first. So I'm going to focus on this triangle. So area is 5 times 10, base times height, and divided by 2. Area equals 50 divided by 2. Area is 25 square units. All right, so I can go ahead and use the formula area of the base times height. We already know the area of the base is 25. 25 times the height, which is the distance between bases, 6. Give you 150 cubic units. Moving on to cylinders. And the only reason that cylinders would be slightly difficult is because you have to use pi. And that's hidden within capital B, because you have to find the area of the base. So the area of a circle is pi times the radius squared. And if you want to break that down even more, pi times radius times radius. Let's go through a refresher. This is a radius. This is a diameter. The word radius is shorter, and it's also referencing the shorter line. The word diameter is longer, and it is the longer line. So longer word, longer line, shorter word, shorter line. You always need the radius. So let's say that the radius in this one measures 5, and this is 10 units tall. Let's go ahead and pull up a calculator and do 3.14 times 5 times 5. So we get 78.5 for the area. So that was 3.14 times 5 squared. Area equals about 78.5 square units. So what we just did was we found the area of the circle. Okay. Now all we have to do is we say that, okay, so 78.5 is layered 10 times. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Going all the way across. You stack it up 6 times. Pretend there's 10 coins stacked up. So to plug that into the volume formula, it's going to be the area of the base, which was 78.5. And then however many times it was stacked up, or the height, the distance between the two circles, which is going to be times 10. Volume is going to be 785 cubic units. And the only reason I put one with a diameter is just so we can follow the same process. So I'm just going to go ahead and write 10 right here. And everything would be the exact same except for the very beginning of the problem would be a diameter converted to a radius. You can see that a radius goes halfway across and a diameter goes all the way across. So whenever we're going to look for a radius from a diameter, we're only looking at half the line. So half of 10 is 5, which matches up with this one over here. I'm not going to go through the same process because the answer is exactly the same. But I just wanted to make sure that we're looking at a diameter, we're looking at a radius, understanding that the area formula requires a radius. Pyramids. So pyramids, the reason that it's 1/3, or you're going to be dividing the area of the base times the height by 3, is because the volume of a pyramid or a cone is approximately 1/3 of its rectangular prism counterpart. So pyramids and cones come from cylinders and rectangular prisms. So if you found its equivalent volume of its rectangular prism or cylinder counterpart, you would see that it's exactly 1/3 of each other. So let's start with a pyramid. So the area of the base. All right, so base is going to be where the right angle sits. That's what that'll tell you. And it also tells you the height of the pyramid. So the base in this one is going to be a rectangle. Let's go 5 by 6. Let's say the pyramid is 10 tall. So the area of the base for a rectangle is length times width. And I'm just finding capital B right now. The length and width are 5 and 6. So area equals 5 times 6. Area equals 30 square units. Now we can go to the volume formula. Area of the base, which was 30, times the height of the pyramid, which is 10. And then we're dividing that by 3. We're taking 1/3 of it. So we're chunking it into 3 parts and taking 1 part of it. 30 times 10 is 300. Divided by 3 is going to give you a volume of 100 cubic units. So you're looking at basically taking what you've already done and dividing it by 3. It's the same thing as a prism. So pyramid, prism, directly linked. The only thing is, since you have 3 dimensions, you're dividing it by 3 instead of 2. All right, and moving over to the triangular pyramid. This one gets a little bit more sketchy because the area of the base formula changes. So if you had, let's put a right angle right there, a base and height of 4 and 5, and you had a height of the pyramid of 10. Okay. So capital B, area formula for the area of a triangle. Since we have to find the area of the triangle, it's going to be base times height divided by 2. The base of the triangle is 5. The height of the triangle is 4. And you see, I knew that because of where the right angle was on the base of the triangle. Divided by 2. Area equals 20 divided by 2, which is 10 square units. All right, we just found capital B. So now it's volume equals 10 times the height of the triangular pyramid, 10, divided by 3. So, I mean, really, you're dividing by 2, and then you divide the entire thing by 3. So if you wanted to do just base times height and multiply it by the height of the pyramid and divide by 6, you could do the same thing, but that's more of a shortcut instead of using the formula. So then volume equals 100 divided by 3, which would give you approximately a volume of 33 and 1/3 cubic units. I would say that the triangular pyramids are the most tricky, but it's just really knowing the area of the base and just following the steps. Next would be the volume of a cone. Is the same exact process as the cylinder. The only difference is you divide it by 3 because the volume of the cone is 1/3 of the volume of the cylinder. So instead of doing base times height like we did for the cylinder, you're going to go ahead and add in the divided by 3. So area of the base, which is capital B, is going to be the circle. You see I already got a radius laid out. Let's go with 4. And the height, let's do 10. So the area formula for a circle, pi r squared, or pi times radius, 3.14 is pi. The radius is 4 squared, so trusty calculator. 3.14 times 4 times 4. Area of the base is 50.24. Now to put that into our formula, 50.24 with a height of 10, and we're dividing that whole thing by 3. So volume equals 502.4 divided by 3. And the volume is about 167.46 repeating cubic units. So this is the volume of the cylinder right here that this came from. 502.4 is the volume of the cylinder that this cone came from. And whenever we divided it by 3, we found the the volume of the cone. 167.46 repeating. So really, I mean, you could always treat it like a cylinder and then just divide it by 3. And the last thing, a sphere. Very, very confusing, isn't it? All right, so the way you can rewrite and understand this formula is whenever you're multiplying something by 4/3, really you have 4 pi r cubed divided by 3. You can see there's the 4/3 right there. So if you want to write it like that, it makes perfect sense. And that's the way it should be written because typing 4/3 in your calculator gets a little confusing. So I'm going to go through this slowly and see how we do. So a radius of 10. This is another thing. You can see here that you have the radius in the formula again. Got to have a radius, the short one. radius. Okay. So really this thing can go in any direction, back, forward, up, down, and it covers everything around here. And the reason that you're doing the radius cubed is because it's three-dimensional. It's no longer two-dimensional, left, right, up, down. So let's go ahead and fill in the formula. V equals 4 times 3.14, which is pi, times our radius, which was 10, cubed, divided by 3. What I'm going to do first is this 10 cubed. I just want to make sure that I'm getting all the little tiny math out of the way before I do all the big stuff. 4 times 3.14 times 1,000 divided by 3. Now all we got to do is type it in. 4 times 3.14 times 1,000. So that went to 12,560 divided by 3. Volume of this particular sphere divided by 3 is 4,186.6 repeating, or 2/3 cubic units. And I know that doesn't mean much because that sounds crazy, but whenever you have a number like 10 and it's being cubed, it sounds like it's a really big number because it is. But I mean, that's a sphere in a nutshell. And really, it breaks down the same every single time. And the only time that it would be something different is whenever you have the diameter that goes all the way across. You just have to turn it to a radius by cutting it in half.